Until the end of the talk, but thanks anyway. So this is my first time in Greece, so I guess a little introduction is in order. So I'm Nicola Franco. I'm a developer and an architect. It depends on who I'm talking to, because now when you say you're an architect, developers might, sneer at you, and if you say you're a developer, project manager don't like you. So I've always been working as a consultant. For now more than 12, 13, something like that years. I'm a teacher and trainer. Obviously, I'm also a speaker. I hold two blogs. One is about Java. Oh, when I turn my head like that, you hear me better. Yeah. Is it better if I always speak like that? I will set the mic in the front. Like that. Okay, and one is about the Vaadin web framework. Who knows about Vaadin? Great, many people. So I'm very proud to have been one of the first, if not the first author writing about the Vaadin web framework. And my latest book is about integration testing, which means that, I'm not perhaps an expert, but I've digged into the subject quite intensively recently. When I'm not doing all this stuff, I'm working for a company called Hybris. Hybris is an e-commerce company. It rocks. It sends me on conference, so you're welcome to have a look at it. And the good thing is, once a year, now we have headquarters in Munich, and once per year in Munich, you have this little party where you can put leather pants, and if you're a man, or dress if you're a girl, and have beers with colleagues. So enough with that, let's talk about real stuff. This is integration testing. So first I will try to define what is integration testing, what are the unique challenges of integration testing. Perhaps I will hint at some solutions. Afterwards I will take two very important examples, which is how can you test when you have dependencies, infrastructure dependencies such as databases, or web services. And then if time is low, because we are already quite late, I will show example of how to do that with Spring and Spring MVC, and perhaps in the Java EE world. So let's go to basics first. You might know there are many different kinds of testing. Last week I stumbled upon an article which described more than 100 kind of testing flavors. So of course, nowadays everyone is used to unit tests, but there is also mutation testing, end-to-end testing, performance testing. In performance testing you have different kinds: security testing, penetration testing, exploratory testing, many different kinds. So for this talk, we will just restrict the scope to unit testing and integration testing, because integration testing can be very well defined in regard to unit testing. So unit testing, as everyone knows, is testing a unit in isolation, like its name implies. So by opposition, integration testing is testing the collaboration of many, or at least two units. A concrete example of that, let's have a prototype car. So you are a car manufacturer, you want to create a new car. By unit testing the car, you would test every nut and bolt and piece of the car itself separately. And integration testing would be taking the assembled car onto a test drive. And the funny stuff is about that, especially regarding what happens on the internet, is there is no opposition between them. They are complementary, because would you take the prototype car on a test drive without having tested every pieces separately? Probably no. And on the contrary, would you manufacture the car by only taking it to a test drive without testing the piece separately? Also, probably no, it would cost too much. So in the end, you would probably end up doing both. And that's, if you have to remember something about this look, is please don't oppose unit testing and integration testing. You will probably need to do both. A new concept of integration testing that is not in unit testing is the system under test. And basically, the system under test is the piece of the system that you want to test. So if you want to do end-to-end testing, for example, the system under test will be the entire application. But perhaps you want to restrict the scope of the testing to certain classes. And this is called the system under test. And techniques from unit testing can be used, such as dependency injection or test doubles. This is not specific about integration testing, but testing is about return over investment. Basically, what time and energy you invest in your test versus the risk and the cost of not testing. So, my experience has taught me that the larger the system under test, the more fragile it is, the less maintainable it is, and thus, the smaller the return over investment. So, when you think about testing, when you think what energy, where you will put your effort first, I suggest you to have a very large base of unit tests, then have a little less integration test with very small scope, then even less integration test with wider scope, and perhaps 1 or 2, 3 tests depending on the size of the application of really end-to-end tests. Integration testing is very interesting and gives you confidence in the assembled application, but there are also some challenges. The first of them is the brittleness. Because when you do integration testing, you probably are dependent on external dependency, such as databases. Databases is a very common dependency. Nowadays, we see more and more applications having dependency on web services. So this is another dependency. But you can also have file system, whatever. So this is a big problem. Given that you are dependent on many other dependencies, either classes or resources or stuff, integration testing might be slow. And finally, since there is a system under test, that means a big ball, and when something breaks inside the ball, you have to know exactly where. And that's the problem with integration testing, that many people, when something breaks, you don't know where to fix it. So that's the main 3 reasons why people are worried about integration testing. It doesn't mean you cannot do it, it doesn't mean you shouldn't do it. It just means that you have just to take care of those 3 points. So, how can we cope? Very easily. So, quickly, first you have to separate your integration test from your unit test. The second point is you have to fake the required infrastructure resources. And the third, to make sure, is you have to test in container. So, once you have separated your unit test from your integration test, what does it mean? It doesn't make your integration test run faster. That would be too easy. But the thing is then, you can run your unit test first, and if they break, and they will break fast, that means then you can go onto your integration test. So always prepare your build so that you fail fast. So make the integration test run after the unit test. And it's very easy if you use build tools. Who is using build tools? Nearly everyone. So in the Java world, we have some build tools such as Ant, Maven, Gradle. Who is using Ant? Sorry for you guys. Who is using Maven? Great. And now, who is using Gradle? I'm also sorry for you guys, but not for the same reason. I'm sorry, I don't like Gradle, but okay. So in this presentation, I will focus on Maven. And you might not know it, but Maven already has a concept of integration testing. For example, you know that the Maven lifecycle is divided into phases. You have the compile phases, you have the test phases. Not so many people know there are also 4 phases at the end of the lifecycle called pre-integration test, integration test, post-integration test, and verify. And those are explicitly made to make your integration test run. So Maven can already divide and separate between integration and unit tests. So you might know that Maven is based on a plugin architecture. And how does it run your unit test? It uses a plugin called Showfire. And Showfire is a plugin that is bound to the test phase by default. So when you run ambient test, it calls the previous phases, all plugins of the previous phases, and the Showfire plugin. And the Showfire plugin by default will run every test phase that ends with tests, that starts with test, or that ends with test case, and that are set in the SRC test Java folder. So, what did the developer do? They just copied, pasted Showfire, and they called it failsafe. Showfire, failsafe. Very, it was a joke. It's really failsafe. It's the same kind of Showfire in different way. Okay. Bad joke, sorry. But it has different defaults. So it will run tests that ends with IT, starts with IT, or ends with IT case. Whereas Showfire has only one goal and maps to one phase in the life cycle, you have different goals and one per phase. So you have a pre-integration test goal, you have an integration test goal, post, and verify. The very important thing to remember about failsafe, it has to be bound explicitly. So when you run MVN test, it runs Showfire. When you run MVN integration test, it doesn't do anything if you didn't bind it. So how do you bind it? This is an example. So I declared the plugin, and I bound the integration test goal to the integration test phase, and the verify goal to the verify phase. So when you do integration testing with Maven, you just do that, it works. Now for continuous integration, once you have that, it's a no-brainer, really. And depending on the time it takes you to run your integration tests, you can run them daily, hourly. I would not suggest to run them on every commit. It really depends on the time of your particular project. So I told you about infrastructure dependencies. And in fact, I told you that, yeah, of course we have the database, but there are many more dependencies. The file system might be one. If you have batch and you want to test that your batch is launched at the exact right time, time is a dependency. You can have message queues, you can have mail server, FTP servers. So when you think about your application is not only code, you have many, many dependencies. So of course, you would say, oh, but let's mock those dependencies. Yeah, of course, when you want to test your service layer in isolation, you can mock your DAO. But if you want to test your DAO, would you mock your database? It makes no sense. It really makes no sense. It's not possible. So in this case, we won't use mocks, we'll use so-called fakes. And let's take for a very, very simple database use case. Let's pretend you are using Oracle in production. Who is using Oracle database in production? Not so many. I will choose my use case better next time. And basically you have 3 options. The first option is you use an in-memory database, such as HSQL or H2. And you hope that the mismatch between H2 and Oracle is not big enough to cause problem in production. What you can also do is you have to install Oracle Express on every developer's machine and on the continuous integration server. But still, Oracle Express is not really Oracle. So you still have to hope and that you won't get into trouble because of a small gap. What you can also do is to create a dedicated remote schema for every developer on your team. And then probably it will cost much space and your DBAs will hate you. So there is no perfect solution. It really depends on the context, but at least you have options to do that. In order to reduce the database risk, if you use another database, so let's say you want to use H2 and you have Oracle in production, you can have this mode. I will try to use it. Yay. So it means you will reduce the risk. You won't completely remove it, of course not, but at least you will a little reduce it. So I suggest you to use H2. So databases are quite common, but nowadays web services dependency are becoming more and more widespread. You can think about web service and separate them into two groups. Are they hosted on-site or hosted outside? Well, it doesn't make any difference in the end. What you want, the difference you really want to make is, are you dependent on RESTful or SOAP web services? So for taking RESTful web services, what do we need? We require an HTTP server. It should be easy to set up, standalone, and embeddable. And so far, I didn't find any that suited all those requirements. We can use Spring MVC, but it's still not very, very easy to set up. Though with Spring Boot it's better, but it's not lightweight and there are too much code to write. So what I found, the very simple stuff is called Spark. Who knows about Spark? Great. For those who don't know, you really should take a look at it. It's a micro web framework, so basically it's very, very easy to set up, and it's inspired by the Ruby Sinatra. And in a very few lines of code, you can set up a web server. How does it work? Basically here you've got the Spark sample, you set the port, and here it means when you get hello, then you will return hello world. Hey, notice how good it is. I am not very good at Lambda, at functional programming. Of course, if you are stuck with Java 7 or below, you can use normal anonymous inner classes. And here you have an example of a parameter, so you can reuse a parameter in your request. And here you have an example of how to set the response status. So, in a very small snippet, you can take your web service, your JSON web service. So, if you have this problem, just look at Sinatra. Now with SOAP. SOAP is a little more complex. We could use Spark and create a huge payload of XML, but of course it would be very unwieldy in the first place. So I would suggest we use something done for that, which is called SOAP-UI. Who knows about SOAP-UI? Great. So SOAP-UI is a very good application. It has a user interface, it has good documentation, it has support, it understands many stuff around SOAP, and it can be used to fetch SOAP web services. So how does it go? We get the WSDL, either online or from a file. We create a mock service out of it with the GUI, and we craft the response. We run the service, and then we point our dependency instead of the outsourced web service to localhost. It's done. Okay. Seems like a dream scenario, because how do we craft the response in the first place? Because, you know, generally speaking, the SOAP payloads are very big. And also, what I described to you is I use an interactive scenario. So, yeah, we point, we click, and we start with the stuff. And we want to do that in an automatic way. So how do we achieve that? There is an API. I won't describe it. You will have a look in the slides. But there is an API. So you can create your scenario, your fake response with the user interface, and then save the XML, put it in your folder, and with the API, reload it afterwards. And then you can run it in an automated way. And then you will have a more SOAP web service. There are a few rules, because also it's very hard to detail everything, but there are a few rules I would like to enforce. This is an ideal scenario. In real life, I would suggest you some stuff. For example, as for unit testing, you keep your validations very simple. You test one thing, which means one assert or a couple of related asserts. Keep your setup very simple, at least the simplest you can. Don't put complex logic. If possible, don't put too much logic. If possible, don't put logic at all. Your test must be readable. Don't try to be very smart and trying to put stuff in common. Copy-paste is okay. In production code, copy-paste is okay. In testing code, even more so. So make it just as if your test could be standalone. So now to continuous testing. So we tested collaboration. We faked the infrastructure dependencies, but we forgot about the most important dependency. And today, the most important dependency is a container. Who is not using neither Spring nor Java EE? 3 hands. That's good. Almost. It depends. It depends on the use case, but nearly everyone today uses a container. So either you use Spring, or you use Java EE, or you use both Spring on top of it. So Spring is a proprietary container, whereas application server are standard containers. I'm more a Spring fanboy, so I will have a more detailed view of Spring, but if time allows, I will try to tell a few words about Java EE. So let's say we have a Spring application and we want to integration test it. So far, we can test beans, which dependency can be mod, so the service layer, we mark the DAO, or the repository. Beans that depends on fake resource. We have seen how to integration test repository by providing a fake data source. But what about the configuration? So basically people who are telling, hey, unit test, now I have 100% code coverage. I put everything in production and now it breaks because the configuration has not been tested. Yeah, testing the configuration is the most basic thing you should do. So, how do you test configuration? Probably you want to test configuration, not the whole application. You want to test different fragments of your application, so you also have to do the same thing with the configuration. So the configuration, whether you use XML or Java config, has to be broken down into fragments. And each fragment can contain a set of real or fake beans. For example, let's take the data source configuration management. Here I will have my main configuration with the service layer, the repository layer, and the repository will depend upon something which I call the data source, which will be of type data source. Then I will provide 2 different fragments, one of test, one of production. The production one will use GMBI, the testing one will use a direct connection to either a fake database, H2 something, or my own schema as Oracle as I described before. And I can assemble, so here the application in production would assemble those 2 fragments, and the application while testing would assemble those 2 fragments. And then they will be complete. So with XML, how does it work? This is my production fragment, and this is my integration testing fragment. And here you put it in your head, this max active equals 1, and I will go back to it later. How do you organize the structure? The main fragment, of course, contains repository and service, as I told you, and is put in the SSC main resources. The production will be set into the main, and the test will be set into the SSC test resources. And so with Maven, you can assemble the fragment you like in the configuration you like. A couple of tips. I have done some mistake in my life, so what I'm trying to tell you is don't make the same. Don't reference configuration fragments into configuration fragments, because then you will couple them together and it will be a huge mess. Basically, how do you assemble fragment? It should be the topmost class that should do it. For example, in test, it should be the test. In the real application, it should be the web.xml that reference every other fragment. I told you about the max active. So one thing that integration testing is very good at is testing exhaustion pool. So basically, when you use a connection pool, a database connection pool, sorry, I'm not too used to Greece sunny climates, and I need to drink. Yeah, so you take a connection from the pool, and normally you would set it back as soon as you don't use it anymore, and you have been told to set it in a finally block, and blah, blah, blah. Yeah, guess what? Sometimes, at some point, forget about it. So at some point, you take more connection of the pool than you put them back. And whatever the limit of the pool, at some point it reaches 0. And what happens when you want to take a connection of a pool who has 0 connection available? Yeah, it doesn't work anymore. So your customer is waiting like crazy, and then you enter the timeouts, and then you have a bad exception stack trace, and you just kill your application. And in many contexts I have been into, at some point, 2, 3, 4 times a day, they were rebooting the server so that they could renew the connection pool. And this is not fun stuff. So setting your scenario of integration testing with one max active connection, you will normally, in most cases, check whether every connection that has been taken has been returned to the pool. So this is a very good thing to do. And this is not about testing if you don't know about Java config. If you are still using self-annotated classes, you should use Java config. So please, who is using Java config with Spring? Who is using XML? Okay. Who is using annotation on the classes themselves? XML, and the last guy, please check Java config, is very nice. It just replaces XML with better stuff. So now, how do we test? Because we have access to both the entry point and the endpoint. Spring provides a module called Spring Tests, and it integrates with most common testing frameworks of the Java world, mainly JUnit and TestNG. And you might notice that I crossed out JUnit. So I am an opinionated developer. I think that TestNG rocks. So you should favor TestNG. There are a couple of reasons. I won't go into detail because I'm really running out of time. But the main reason is the following. With TestNG, you can order your test methods. What does it mean? I told you previously that in some integration testing scenarios, it was very hard to find the cause of the error if it broke. Why? Because probably for integration testing with JUnit, you have very, very big methods, like perhaps 50 or 100 lines of code that are doing some stuff. For example, I'm running an e-commerce shop. One of my integration testing scenario is how can I test the checkout? So what do? First, I try to log in a customer, then I try to go to a product detail page, then I try to take the product into my basket, then I go to the checkout page, then I go to the payment page, then I pay, and then normally I should receive a confirmation that I've ordered the article. This takes time. It takes a number of lines of code that is huge. And if you set everything into the same method and it breaks, yeah, when you've got the exception, it will say, checkout doesn't work. Too bad. What I want to do is, in which step didn't it work? Was it in the login? Was it during payment? I don't know. I want to break all this big method into many different small steps that follow the natural order of stuff. So I want to have a login method, I want to have a product detail method, I want to have all these kind of methods. And if one of them breaks, I know in which step my scenario has broken. And with JUnit, I'm sorry, you cannot do that. Or you have to use the names of the method. And you will say 1, login, 2, and it just doesn't fit my use case. What you can do with TestNG is you can say that one method is dependent on another method, or one method is dependent on a group of methods, or I don't know. So you can say dependency between methods. And this is hugely frowned upon for unit testing. Unit testing should be made in isolation, but for integration testing, it's really a lifesaver. So if you don't know about TestNG, probably you should have a look at it just for this use case. How does Spring and TestNG integrate? Very well, thank you. So you have this, and I won't tell it out loud because this is why many people outside the Java world are making fun of us. Yeah, it is very long. So you just inherit from this class, and basically you are done. And if your test is transactional, you should inherit from this class. Atop your class, you should set a context configuration annotation and point to the configuration fragment I told you about previously. And then you can inject anything, any bean that has been set into any of those fragments into your test class. And if it doesn't work, and it always works, you can even use the application context attribute from the superclass. But that's not good, but you can do it anyway. So how does it translate? You've got your integration test, it ends with IT, so Maven will automatically run it with the failsafe plugin. It extends this class, and here the context configuration references to two fragments, the main config and another config. And then I can auto-wire, I can inject any bean I need that has been configured into one of those fragments. I can call any method on it, and I set whatever you want. So it's very straightforward. Probably at some point you will want to test with the database. So for example, if you have an order service, you want to check that the order has been set in the database. Remember, normally the transaction should be bound to the service layer. So traditionally we have the controller, the service, the repository. The transactions are a business concern, so they should be set on the service layer. If you are testing your DIOs only, so you are testing DIOs, very complex queries, of course, you won't just test your DIO to insert or update. You just have very complex query that you want to test. Then you have to use explicit transaction management with transaction, because probably the service layer will normally handle the transaction, and here you have to force the transaction. About transaction management, there are many mistakes you can do. Tests are good, and probably tests will fail. That's really the objective of tests, that they fail sometimes to tell you something bad is happening. When test fails, generally, when it's connected to the database, what I want to check is, the state of the database. The funny stuff about Spring is that by default, Spring will roll back transaction. Yeah, that's not funny. Probably it was in a time where everyone would use the same database. So you wouldn't want to change the state of the database. That's one of the few implemented things that I don't like about Spring. It rollbacks by default. It's very easy. to override this behavior by setting transactional configuration default rollback false on your test class. So every one of your test class which deals with database probably should have this kind of stuff. And if you still want to roll back one method, you can use @rollback true on the middle. So how does it work? Here I still have the extends, and now I'm using the abstract transactional test ng Spring context test. Here, this context configuration that we saw previously, and here I set the transaction configuration with default rollback false. This one will be rolled back, this one won't be rolled back. So this one is nice because when it fails, I can look at the state of the database. With Spring MVC web apps, it gets a little more complex, and of course because it's a web. Basically, in web application, which are not Spring Boot web application, who knows about Spring Boot? Who is using Spring Boot? Okay, so I'm still addressing most of the audience, which is good. When in a normal Spring MVC application, basically Spring has two contexts. The one is a main context, which is where you put your service layer, your repository and stuff. And one is a web context when you have your view resolver and stuff. And basically those two contexts are organized in a parent-child relationship. So the web app is a child of the parent one where you have your services, and it can access any bean defined in there. So any child can access its parents' beans. The opposite is not true. So you would like to do the same in your integration test. And also, you don't have a normal application context, you have a specialized web application context. So we have just the annotation for that. Here you say that you want a web app, not a normal application context, but a web application context. And here you set the context hierarchy. So now you have to organize your fragment in a parent-child way. And how does it organize them? Yeah, the first to declare is a parent, the second is a child. Quite easy. And if you add a third, it will be the child of the second, and this one will still be the child of the first. So nothing mind-blowing. I will start to get quicker now, because the setup took us some time. Basically, how do you test? Now that we have set up our test, how do you test? We can use Selenium, we can use HTTP units, but there are drawbacks to them. They are very low level, they are very fragile. And I told you before, you test because in the end, you get money, or at least you are not wasting money. So my experience with Selenium, it's very fragile. So testing at the lowest possible HTML, CSS level is perhaps not the best score you can get. You can have 1, 2, 3 tests, but not many more. What you can do, you can test at the controller level. So you would use a controller at the entry points. In this case, though, you will bypass many stuff that your application requires, such as interceptor or Spring Security or whatever. So you still want to test with them. Guess what? There is Spring Test. Spring Test also provides that. And it's quite old. It has a large part of it dedicated to testing MVC application. And the good thing, you can test with URLs as entry points. So you will still trigger the interceptors and the filters and whatever. It's a Fluent API with static imports. I won't go into the detail again, but this is the centerpiece of the stuff, the mock MVC class. And with the mock MVC class, you can have request builders, result matcher, and result handlers. So the request builders will be used to configure the fake requests, because what you want is you want to send a specific payload to the application, and you want to check that the result is what you're expecting. So how do you create the specific payload with the request builder? The request matcher are a session. You will check that the return result is what you expect. And the request handler is something that you can do anything with the request. And basically now you can, out of the box, there is a logger, so you can see what you sent. It's just for logging purpose, but you can do anything you want. As always, string-of-rule interfaces, so you can plug in your own implementation. So how does it work? First, your entry point, you set the HTTP method that you want to use, so it's the name of the static method, get, post, delete, whatever. You can set HTTP-related stuff, such as headers, parameters, content, whatever you want. And you can also set Java EE specific stuff, such as request attribute or session attributes. So very simple. Simple. It's hard to say that. Simple. Here I will use a get method. I will set it to customer ID. And this is a cool thing because ID between brackets will be replaced with this stuff at runtime. I say accept text HTML, so in the end I will have this HTTP header. I will set a parameter long equals en, and you find it in the final request, and I say secure. And there is a very simple mapping between two. So whatever HTTP request you want to craft, to test, you can do it with a Spring MVC mock API. Matches, you can have many. You can check that it's forward or redirect or JSON payloads. You can check, and from the less useful to the most useful, so I will talk about that. You can check that in the end of the request, in the end of the request, you have something in your view, that the view is this one, that, for example, who knows about the Flash attributes in Spring? Okay, Flash attributes are very important. I will take a little minute to explain them, because you know, generally speaking, when you want to pause or to put something, what you can do is, you send the request, and then if it takes too slow, what does the user do? He presses F5 repeatedly, because it's taking too long. So what you like to do is you use post redirect get. So you handle the post very quickly, and you immediately send a redirect to a get. So if the guy presses F5, what does he do? He just refreshes the page, and it's idempotent, so you don't care. And how do you handle that? Because probably when you posted something, there was something in the request, and when you redirect it, you don't want to put all those parameters on the URL. So Spring handles that with Flash attributes. So if you want to implement post redirect get in Spring, just have a look at Flash attributes. They're so cool. And you can also test that. You can test the HTTP code, the cookies, and stuff like that. And I'm already running out of time. Can I finish my slides? I'm talking to the guy in the back row.
Yes, of course. Take your time.
Okay. So I have not many slides. It's about the Java EE world, because I told you I'm a Spring fanboy, but some of us are still using Java EE. Java EE has unique challenges in integration testing, because Java EE uses CDI for wiring your beans together, and basically you cannot choose which beans you are using. There is no explicit wiring. Basically it's auto wiring all over the place, and you have no choice. And I don't like auto wiring. Anyway, that means that when you want to test your Java EE application, you have to put everything together. And as I said, I don't want the system under test to be the whole application. I want it to be more restricted. And also, probably you are using Java EE because you have been told that it can run on all compliant application servers, which is not really true. But anyway, you still want to test if you have a product that it can run on a certain set of application servers. So there is a cool project by JBoss called Shrink Wrap. And Shrink Wrap lets you decide what you want to deploy on an application server. So basically, it will be pick and choose this class, this package, this resource, create it as a jar, and you're done. So you can choose what you deploy. So in different integration tests, you know what you will need, so you will just pick and choose the required resources. It has a Maven integration. I think there is a Gradle integration too. So how does it work? Yeah, here, even if you know nothing about Shrinkwrap, the API is really cool. You create a web archive. This is the name of your archive. You add this class. You add every class that is in the same package as my model. You will add under webinf the persistent.xml that you will find it here. You will add as a webinf resource this file, so it will take this this webinf page.gsp and put it into webinf into your deployed application, and do the same with your JavaScript. And then, here it's webinf, here it's webnormal. So it will put it at the root under the script folder, and you will use this web.xml. So in these few lines of code, I've deployed into WAR some classes, my persistence.xml, a GSP, and a JavaScript. And of course, the web deployment script. As I said, integrates with Maven. So you don't, if you are dependent on libraries, which probably you are, such as the loggers, SLF4G might be a good library to use. You don't want to, during your integration test, okay, how do I take this library, SLF4G, which version, and again, no, Shrinkwrap can read your POM. So you can load everything from your POM and import every dependency that is compiled and runtime. And of course, you can check whether it's transitive or not, and you add them as a library, and they will be put into the webinf/lib folder directly, easy. So it's very powerful. So that's the first problem, is how do you package, how do you pick and choose your resources into the deployed server? Now, how do you deploy to many servers? And Shrinkwrap is a sub-project or a bigger project called Archinian. And Archinian's sole purpose is to test your application on different application servers. So it lets you download, deploy, and test application agnostic of the application server. And then the application server is configured. And there are many configure container adapter, Tomcat, Tommy, JBoss 12, whatever. There is even a WebSphere one, but only one for a single version. So for those who are stuck with WebSphere and WebLogic, I'm sorry. Anyway, it strangely looks like a Spring test. So you extend, it's still with TestNG. I'm sorry, I really am a TestNG fan. So it extends Archinian. Before we extended abstract TestNG context Spring test. You can auto-wire in the same way. Now it's not auto-wiring anymore, it's inject, because this is the standard annotation. Here, you will notice that this is a public static class which you created the archive previously with Shrinkwrap. And then you can test just as before. You call myservice.method and you accept blah, 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 blah. So it is quite easy. And on the configuration ports, basically here I configure a single container, which is a Tommy container. I don't forget to set the dependencies into my POM, and I'm done. So here, if I have some more minutes, I can answer some questions. And meanwhile, if you are interested in that, you can look at this very good book. I have even a copy there.
We have time for 3 short questions, and then you can meet Nicholas outside the coffee room. Do we have any questions?
If you speak out loud, I think you don't need
Yeah,
the mic.
I can try. So you said you basically cut off UI testing from integration testing, is that right?
Yeah. Because my experience is that, you know, it's like doing integration testing without unit testing is not relevant, but doing UI testing without having done integration testing in the third part is also not relevant. UI testing is the most advanced part of integration testing, in that the system under test is a whole application. And it also offers unique challenges. And for example, yeah, you have to implement the patch pattern because otherwise your tests are very fragile and very different stuff like that. So it has many more challenges. So first do integration testing right, and then you can do UI testing right.
And okay, and do you think that's because the tools for it are not available there? I mean, you said about Selenium being so fragile. Is it because of the tools, or is it just because it's harder as a process?
It's because how we use the tool. Basically, what you do with Selenium is that you are using selectors, CSS selectors, for example, to say, okay, I will select this button, and then just afterward you say, I will click on this button. And you do that in all your tests. And then, I don't know why, but the UI is the most evolvable stuff in your application. It changes every time. So your CSS selector won't work anymore. And so at some point, every one of your tests will break. Because, yeah, the front-end guy just decided that it's cool to rename something. So there are techniques to mitigate this risk. But yeah, it's the most fragile stuff. That's why I love Spring Test, because it lets you really test at the URL level. So controller is too low, but URL are generally stable. Generally. And at least they are done by backend guys, and backend guys don't change their URL so much as front-end guys change their CSS. I'm not bashing the front-end developers, they do it because of business requirements and stuff, but yeah.
Thank you. Next question.
Hello, I have two questions.
Only one is
Only
allowed.
one.
Only one is allowed, I'm sorry.
Okay, from the configuration you have showed us in your slides, I assume that every application concerning integration testing has a list of libraries which is accompanied, and every application you make loads its databases or external dependencies during runtime in the continuous integration server. So you have H2 for database, it loads on runtime and makes the schema changes and the integration tests you like to do. If a project depends on NoSQL databases, maybe search engines and other stuff, how do we do that?
Depends. The problem is, NoSQL is not very mature at the moment. It's still very fragmented. Everyone is doing this stuff. For example, SQL is, yeah, you've got JDBC drivers. We've got no such stuff for NoSQL database. Spring is trying to do something with Spring Data, but it's still very fragmented. So it really depends on the database. For example, if you're using MongoDB, there is something called Fondo.
My point is that sometimes we have to bind our continuous integration server with some databases, search engines, and the project cannot stand itself for an integration test. You have to.
It depends. It really depends on the. As I said, I have described many dependencies, and some of them I have solutions for because I had the problem and I've come up and searched for solutions. For MongoDB, I just searched and I found this available and it works. But if you are using, I don't know, Redis or Neo4j, you have to check the API. How would you do that? And probably it will work very badly. And yeah, it's a maturity of the tool. And I think that when you choose NoSQL technology, you should be aware of this problem. So you should list it in your design and page column, whether to choose this technology or not. It will be harder to integration test. Welcome to the new world of tooling choosing.
One final question.
Thank you very much.
Well done. Okay, sorry.
How do you deal with how do you deal with problems that are data specific? There are sometimes that the bugs of the problems break due to different data. The combination of the change of code with data that is not the same on the mock data, but it's many times apparent in the production data.
So
How can you deal with it?
I couldn't address it in the presentation. I tried to address this in the book, so you... Okay? Yeah, this is shameful self-promotion. I'm sorry, but basically, I used something called DB units. But now you can do it, I don't know if you're using Spring, but Spring also provides its own schema stuff and data loading stuff. Basically, what I try to have is very, very small data sets for each integration test. So I don't use a data set for all my integration tests. I use a very specific data set for every one of my integration tests. I try to name it as an integration test itself. So when it breaks, I know where to find it. I know which data set I have to change. This is, you know, it's not rocket science. It's just that I've made mistakes and I have, come up with solutions, and some of them are easier. But probably if you have had the same experience, you would probably have come up with your own solution or the same problem. It's really common sense.
Thank you very much. Thank you very much, Nicolas.